Hi everyone, myself Jyoti Prasad. I am coming from RM Engineering College. In this video, we are going to discuss about the instruction execution and straight line sequencing. How the instruction is going to execute, how the straight line sequences has been done, what is branching, and nothing but loop. What we are going to study in this particular video. So, for example, if you want to perform a task or a segment, say C is assigned with after performing A plus B. So as it appears to the computer like this, C is assigned with the result of A plus B operation. So this code is written with the assumption of the computer allows only one memory operand for instruction, only either A or B. So only one operand will be allowed at a time. So with this, we are going to perform this A plus B operation using processor registers. We know processor registers are from R0 to R5 registers. So this type of registers we are going to use for calculating this A plus B operation result. The three instructions, here we are going to perform three instructions. First, A is allotted, then B value is added to A, then the result will be assigned to the C. Like that, three instructions of the program are going to execute in three successive locations. If at all I am going to start, we are going to start at a location I, then each instruction will carries 4 bytes of length. So then the second instruction will be start from I plus 4. The third will starts from or carries at I plus 8. So the what are the steps of program execution means the processor contains a register called program counter. So in the previous videos we might have seen instruction register IR and PC. So what is the program counter? Program counter contains means these will carry the address instructions to be executed next. What will be the next instructions to be executed? So it will have all the list of that. Okay, the processor control units use information of this program controller to fetch and execute the instruction. So this can be carried out in a straight line sequencing. This is nothing but according to that list, it will fetch and execute type of operation is called as straight line sequencing. During the execution of each instruction, it is incremented by 4, like I said, 4 bytes. After the move instruction at location I plus 8 executed, the PC contains the value I plus 12. Likewise, it will carry all the address to be executed next. So it will keep track of all the things for the program counter. We can execute the given instruction in two phases or two-step procedure. First phase it will fetch, second phase it will execute. What is meant by fetching means, like I said in parallelism, the program counter how it is going to fetch the data, fetch the operands to be executed next, called fetch. The instruction is fetched from memory location whose address is in program counter. Program counter is having all the list I plus 4, I plus 8. From that memory location, it will fetch. So then the instruction is placed in instruction register IR. This will execute that. That is the second phase. At the start of the second phase called instruction execution, IR, the whatever the value stored in IR can be examined and the operation will be performed. The next instruction, it will be fetched parallelly when it is executing. Second phase is carrying on. The first phase will be loaded. So this is why it will perform in parallelism. Branching, like I said, branching is also one of the program execution, where if at all, if we go for comparison of two programs, the first program the left side is first program is I plus 4, I plus 8, which is having first instruction move, second instruction is add. I mean the number 1 is added to num 2, then that result is added to num 3. So all these things at last, whatever the R naught is having the information that the some value will be assigned to the R naught. Some value will be stored in R naught. That R naught will be assigned to the sum at last. So the sum value will be carried in the operand called sum. But until that, R naught will carry all the sum, updated sum. So to perform this one, we need many instructions. Whereas if you are going with branching instruction, so after all the number has been added, will the result will be placed in the memory called look and the operand called sum. Instead of using this one, we are going to the loop is a straight line sequence instruction executed as many times as needed. Like we use a if or for loop. in our C programming, we the same thing. So we are going to keep a loop, again and again it will add, keep on adding all the things. At last, when the condition fails, the result will be stored to sum. So that can be carried by the instruction called branch greater than 0. Each cycle, the value of branch is not greater than 0. So when that particular condition satisfies, that loop will exit. So here, like I have shown in the right side of the picture, we will have the instructions in this particular marked region. The entire program of three instructions: move, add, like that. The instructions will be there. Each time the count will be decremented. The count is stored in R1. The count is stored in R1. The value of sum is updating iteration to iteration is stored in R0. So when branch is greater than 0, it should go to the loop instruction. Here it will come. Again the loop will repeat. So keep on doing that. When the branch instruction greater than 0 fails, then the last R0 value, the last updated value of R0 is assigned to sum. So in this way, instead of carrying on number of instructions, more instructions, with one set of instruction keeping in the loop, we can add n numbers, addition of n numbers. This is possible by a instruction called branch. Thank you.